Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be looking at compound inequalities. Now, what are these compound inequalities? Well, they are two or more inequalities that are graphed together on the same number line. And so we're going to see two different types of compound inequalities. Type 1 are the OR, and type 2 are the AND. So we're going to begin here with the type 1, and those are the inequalities that are joined by this word OR. When graphed, they look like this, and you'll see here that it's kind of like a broken graph where we've got parts going in the left and right direction. And so the way that we would write this number line, this graphed region on our number line would be the inequality where our x is, and I'm going to actually kind of highlight this for us. Let's do it in our pen here, where we have our x value going this way. What I have in red here, this is where the x is less than or equal to -4. And then on the other side, we have this open circle and it moving to the right. And that is the x value greater than, and that's right between 0 and 2, so that's 1. And they are combined with this word OR. That's what I want to really highlight here for us, that they are combined with this word OR. Why is it combined with the word OR? Because our graph is going either less than -4 or greater than 1. And so that's, even as I say that out loud, you hear me saying the word OR to represent it's going one way or the other way. And in interval notation, the way we would write this is we're going from -infinity, which is an open boundary, all the way to -4. That's going to close. And then we're going to use this little U. That U right there is for the word union. Meaning like the joining together of these. And then a open parenthesis, because 1 is an open boundary, all the way to infinity. So now that we've figured out how to write them in the inequality and the interval notation given the graph, how do we actually go about solving these? To solve these OR inequalities, you're going to solve each part and then graph on a number line to show those solutions. So let's go ahead and do that here with our first. We're going to go ahead and graph. We're going to solve, graph, and write our solution in interval notation. So I'm going to focus here on this first piece and solving it. In order to solve 3x plus 4 less than or equal to 10, I'm going to need to subtract 4 on each side. That's going to give me, on this side, we'll be left with a 3x. And on the other side, it simplifies to 6 when you take and subtract 4 from 10. And to finish it off, what do we need to do? Divide each side by 3. And that leaves us with x less than or equal to 2. So we can go ahead and graph that. The less than or equal to, there is going to be a closed circle on it. And then we're going to be moving less than, which is to the left. All right, now let's go ahead and look at the other portion of our compound inequality. 5x greater than 45. 5x greater than 45. Well, to solve that, it's 5x, 5 times x, so I will need to divide. And whatever I do on one side, We do to the other. 45 divided by 5 is 9. So we have x greater than 9. X greater than 9. 9 is way over here. So open circle and an arrow going in that direction. So there you have it, ladies and gentlemen. We have solved, we have graphed. Now let's go ahead and write it in interval notation. The red portion here goes from, on the left, negative infinity, all the way to 2, and we're going to close it up because it is a closed circle. And then that is going to be in union with our open boundary of 9 all the way to infinity. So there you have it, ladies and gentlemen. That is graphing and writing and solving a compound inequality that is joined with the word or. That is type 1. Now let's look at our second type here, type 2. Type 2 are going to be joined with this word and. And if we were to write this, which we see graphed, you're going to notice here that it is x values, right? X values. Let me actually use my other color here. We've got our x values greater than or equal to 2, right? So right here at 2, it's equal to, and then it's moving greater than that. It's moving in that greater than direction, but then it is also open at 5. We've got these x values that are at 5, not equal to, but actually moving in this less than direction, right? Moving in this less than direction. And that is joined with the word and. Because it needs to be both. It needs to be x values greater than 2 and also, x values less than 5. And what we're looking at here is like their intersection. We're looking at their intersection. Where do both of those inequalities happen? That is this region that is shaded by both of them. In interval notation, how would we represent that graph? Well, it would be a closed boundary at 2 and then an open boundary at 5. It is the values between and including 2, but not including 5. Now, how do we rewrite the and inequalities? How do we go about rewriting them? Because the solutions to an and inequality fall between two endpoints, they are frequently written in this more condensed form. So take, for example, what we just saw. How could we condense this? How could we say x greater than or equal to, this is supposed to be a negative 2, and x less than 5. How can we join that together? Well, ladies and gentlemen, we do like this. We say x has to be between, and then what's the smallest value? What is that smaller value? The one on the left-hand side over here? That's our negative. That's our negative 2, and we want it to be greater than and equal to that, but also less than that value on the right-hand side, which was 5. So a lot of times these and inequalities are joined like this with x between those values instead of writing out two separate ones joined with the word and. So if you see an and inequality written out like we have here in this first example, you can just solve the two parts separately and then graph it. But if it's in this condensed version like you see here, you're going to want to solve it in pieces or all together and then move on from there. So let's go ahead and do example 7 here together so that we have a glance at what that looks like. Let's begin with this first portion here. 2x plus 3 greater than negative 9. What do we need to do to begin solving that inequality? Well, we're going to need to perform that additive inverse, which is to subtract 3 on each side. That leaves us with 2x greater than a negative 12. Then we'll apply our multiplicative inverse and divide each side by 2 so that we have solved for our variable. We'll similarly do so on the other side, which is going to be our first step here to solve 8x minus 2 less than 30. We're going to want to perform that additive inverse, which is to add 2 on each side, giving us 8x less than a 32. And then the last step is always to try and divide by what is in front of our variable. The multiplicative inverse would be to divide by 8, and that gives us 8 less than 4. So ladies and gentlemen, we are looking at the region where x is greater than negative 6. Let's go ahead and put that in there. Where is the negative 6? That's going to be right here, open circle. And we want our x to be less than 4. So the less than 4 is going to be going in this direction, right? And the greater than negative 6 is going to be going in this direction. So that shaded region is everything between those two endpoints. That's going to represent our solution region. There you go. And writing that answer in interval notation, we'd have an open boundary at negative 6 and an open boundary at 4. Now, what if it was like we see here in example number 9, where it is in this condensed version? Well, like it said here, you can solve it all together, and then you can solve it all together working inside out, and then graph to show the possible solutions. Well, what does that look like? Ladies and gentlemen, that looks like, okay, it has my variable here with the minus 1. So how am I going to get that variable by itself? How am I going to go about doing that? Well, I would need to add 1, right? I would need to add 1. And so really what that means is I need to add 1 all around, right? I need to add 1 in the portion that is in the left side, but also then on the right side. And so what does that give us? That gives us now in our central location a less than or equal to and greater than or equal to. Here we have a negative 2 plus 1. Negative 2 plus 1 is just a negative 1. And 6 plus 1 is 7. So there we have it. The inequality is going to be from negative 1 and including it all the way to 7 and including it. All of that on our number line between those endpoints represents our solution. And in interval notation, because it is a closed boundary, we're going to go from negative 1 all the way to our closed boundary of 7. So there you have it, ladies and gentlemen. That is solving the and as well as the or compound inequalities. If you had any questions, would you please take a moment to share those now? And until next time, stay fired up, you guys.